the potential energy would always be increasing in the inflationary phase of the universe. That is, the space would always be in its stretching phase. Now it would stretch more, now it would stretch less, but there should not be a phase of absolute contraction of the spring. In the case of the gravitational relationship between the Sun and its planets, it is known that, in relation to the Sun, the planets will pass, at some moment, at the points of maximum approximation, perihelion, and maximum distance, aphelion. If space were always stretching around the Sun, the planet should pass through perihelion not through direct contraction of space, but as a result of its greater stretching. This is what makes us think about possible variations in the density of the solar mass, influencing the curvature of space. Being negative, the potential energy would tend to be minimal in the aphelion. The space would stretch less, due to the drop in solar density. Space would relax, in this case, if it accompanied the drop in potential energy. The planet would move away from the Sun due to the less stretching of the space around it. The potential energy would tend to be zero at infinity, but that infinity could not be achieved. It would be equivalent to the disappearance of the curvature of space, which would hurt the uncertainty principle. If the potential energy increased, the planet should approach the Sun. This would be expected, as the work of stretching the space, or the spring, would be negative. How to explain that the potential energy could be establishing the maximum limits of approach and distance of the planets in relation to the Sun? The answer would be the capacity of space to generate inertia independently of the masses. In doing so, space would be promoting changes in the density of celestial bodies, and not necessarily in their masses. This hidden interference of space on a universe, in principle static, could explain the relative movement that is observed in space-time. When space is confused with its own two-dimensional messenger, the light, now leveled at its energy extremes by the packaging phase, to which it would have been subjected, the observer could no longer register changes in the density of the stars, by using the electromagnetic radiation they emit. The transient changes in the geometry of space, promoted by these theoretical variations in the density of the masses, could explain the secondary nature of the force of gravity. The secondary acceleration of the planets would result from the greater or lesser void opened in space by this stretching phase. The planet would always be falling into this void, in which gravity would present itself as a secondary force of restoration. A less stretched spring would result in greater distance and less acceleration of the planet, since the spring would be tending to its resting position at infinity. In this case, the void to be filled in the space would become smaller. This would happen with less dense planets, as is the case with Saturn. For the purpose of better understanding of this theoretical model, it can be said that the veiled stretching of the space spring would act as a kind of fictitious force of anti-gravity orientation, because, when stretching, the space would retain the light and the information linked to it. In the case of the Earth, it would feel the changes promoted by space in the density of the solar mass, not in its own mass, without direct record. The Earth would tend to fill the void in a secondary way, giving rise to the emergence of gravity. All the difficulties we face in the current model of the solar system would be related to our points of view. These depend entirely on cosmic radiation to be structured. when looking at the sky at night, there would be no way to separate light and space, or to treat them as independent entities. The most classic example is the conclusion that space would be curved in the vicinity of the Sun, as obtained by observing the 1919 eclipse. The most distant stars at their true positions deflected when, on the way to Earth, their light would have passed in the vicinity of the Sun, now covered by the Moon. In this way, we come to compare the elasticity of the space around the Sun with that of an elastic strip, which is the same model used to describe the harmonic movement performed by light. Another fact that shows the influence of our point of view is the attitude of considering that the Sun would occupy the fixed end of the mass spring set, a model used to describe the harmonic movement attributed to both light and space. The Earth, in this case, would occupy the free end of the set. With this, it is assumed that the 0 point of time would be placed in the position of the Sun, after which would begin the counting of the 8 minutes necessary for the light to reach the Earth. As the spring would be stretched from the fixed end of the set, where the Sun would be placed, it is concluded that the mass of the star is directly generating gravity by causing a curvature in the space around it. This stems from the finding that, when the spring of space stretches, the force would point in the opposite direction to that of the stretch, pulling the Earth towards the Sun. In this model, we usually forget that the light would have been temporarily held in the Sun's future light cone, without any direct record. If that light did not spread on Earth, at some point, we would not know that the Sun would be shining 150 million kilometers from here. On the other hand, when the light spreads on Earth, the Sun is spotted instantly, without taking into account the 8 minutes of its displacement. This suggests that the ground zero of time would have migrated, in a virtual way, from the position of the star to our own position. Therefore, when we were to express our point of view, we should assume the fixed end of the mass spring assembly, and not its free end. This would be fundamental to describe the gravity and the true sense of the action of the potential elastic energy, seriously entering the currently accepted models. Our points of view would promote an apparent inversion in the direction of the arrow of time, whose tip, after the arrival of Sun's light, would orient itself continuously towards our own past. The tool, which we use to measure the position and speed of stars and planets, is the very light they emit or reflect into space. Therefore, we should not neglect the harmonic movement that this light performs. The first phase of this movement is negative, with an increase in the elastic potential energy. Since the phase would retain light due to the negative nature of the spring stretching work, the absence of information would tell us that the first phase would be virtually contained within the observer himself. This does not mean that, despite being temporarily inaccessible, the information was not there, despite everything. When the potential energy tends to be maximum, the kinetics would tend to be zero. This tendency would be suspended to infinity due to the complementary contraction of time in the stretching phase. That is, time could not be measured directly in the inflationary phase from certain limits of its contraction, even if the time module still remained very far from absolute zero. In the case of the solar system, the maximum stretching that would be possible for space would establish, therefore, the immobility of the planet at the point of its maximum approach in relation to the Sun. The potential elastic energy, as a result of a negative work, as happens in an implosion, would be establishing the maximum limit of approach to the planet, preventing the collision with the star. The contraction of time, at this stage, would have another important consequence, at least when it comes to the observer's point of view. This is the virtual leveling between the maximum and minimum energy extremes of solar radiation. Without the possibility of direct access to the information contained in the light at this stage, the observer is forced to wait for the solar radiation to spread on Earth. This seems to shift the zero mark of time, which was previously in the position of the star, to his own position. From there, the observer can make assumptions about what would have happened to the light before it reached him, although without practical demonstration. He assumes, for example, that the Sun would behave as if it were a pontiform center, emitting concentric circular waves, which would overlap over time. This would result in the formation of a cone of light from the future towards the Sun, which would represent an insurmountable temporal barrier placed between the observer and the star.